Hi, this is the Tempter podcast where we discuss embedded Linux, IoT development, and anything else you might find interesting. Your hosts today are Kim Raj and Cliff Brake. We thought it'd be interesting to just kind of think back and try to understand how we got to where we're at and how did we get here with respect to the Yoe distribution. That's what we're going to try to dig into today. And Kim, maybe you can just start off with a little history on your work in embedded Linux and what set you down this path.
Right, yeah. So I think I started with embedded Linux around 2000s, I think. And back then, there were desktop distributions were around, but embedded Linux was kind of new. And there were various companies actually that were building embedded Linux distributions, like companies like Monta Vista, Wind River, Timesys, and so on. They were using some tools like RPM or custom homegrown tools, and I happened to work for one of them at that point of time. Primarily, I was a compiler engineer. From being a compiler engineer writing backend optimizations, eventually I needed a way to put the full tool chain together. And then I needed a way to put a full kind of a test framework in place so I can run benchmarks and test cases. So, and my focus was embedded systems primarily. So I could do it easily on desktops for native x86. But if I have to validate an optimizations on ARM or MIPS, then, I didn't have much out there. So that kind of pulled me into building more than the compiler, and essentially I ended up building full systems and then distribution. So that was small kind of start to how I got into the distributions.
Was this mostly driven by internal needs or customer projects, or what was driving a lot of this?
So most of it was, it's a mix of both. So one of my previous employers, they were a operating system vendor built around embedded Linux. Professionally, that was kind of my requirement at the time. And I was also doing on personal fronts, I was interested in learning more and learning more about software beyond compilers. And, I was very interested to learn about operating systems. And I was looking for ways to compile Linux kernel and debug it, step through it, get the workflow, how the algorithms are working. And so those were like other motivations I had. At one point of time, I was looking at writing my own kind of a kernel as well, just for practice. So I think these were kind of motivations that led me into, basically building systems and go from there. And I'm pretty sure that, it's not only me, and everyone probably have their own unique story, that got them there. So I'm sure you have your own too, and I would be interested to hear about, what got you here.
Yeah, it's interesting to think back. I guess I probably started in the late 90s working for a company that helped develop products for other companies. We were kind of focused on the early ARM application processors. So that would have been like the digital strong ARM 1100, if you remember that.
Mm-hmm.
And then later Intel had a PXA 255, I think, and then a PXA 270. I might have the numbers wrong, but something like that. So these were the first real low power application processors that could seriously be considered for running Linux and low power and handheld applications. So this was kind of a new thing in the late 90s and the early 2000s.
Mm-hmm.
So this company did Windows CE development, which was the predominant OS at the time. And then there was also a lot of community interest, and then companies starting up doing embedded Linux as well. So in the early days, there was the compact iPac PDA. So that was kind of one of the first devices that everybody was interested in trying to get Linux running on it. And then we took those efforts and adapted them to products people were building, that had these embedded ARM processors in them and touchscreen displays and did things for industrial or other applications. So one of the things that kind of stands out to me over this whole time span of the last 20 years or something is really how, an embedded Linux system is more than just the kernel. That's just a piece of it. Building all the libraries and applications that go on top of it is a big part of the challenge. And that's really, in the early days, somebody would put together a rootfs, and we'd kind of hack on that, replace some binaries, but that quickly proved to be unsustainable and not something we could easily maintain or modify.
Mm-hmm.
So from the start, we were kind of always looking for a system where we could build all the software from scratch. We could modify things, customize things easily, and kind of build up our own distributions as needed for these projects. They all had unique needs. I guess that's my recollection of 15, 20 years ago.
Yeah. And I think you mentioned about, people taking a pre-existing rootfs and building their software on top. And that's where actually, some of these embedded OS vendors, especially around embedded Linux, offered full systems, which they basically gave a developer kit, so to speak, to the customers. But these developer environments they offered were basically on top of what they provided them, which is fine if you were to write unmodified, use the platform unmodified and then develop your applications or libraries on top of that. But I remember one of the use cases where one of the customers came back and they said, hey, we know that you provide us a pre-built OpenSSH. We have a requirement to integrate another algorithm in it, and therefore we will need a capability to be able to rebuild it ourselves. Or how can we achieve it? And they were very kind. They said, our product works great. What you give us works very nicely with everything else, but this is a requirement we have. And so how do we deal with it? So the usual way was that, you will open up a professional services department in your company and they will handle these kind of requests. Now, what was happening more in the back of my mind at that point was that what we have today is basically not meeting the upcoming requirements of everyone. And the OpenSSH, a simple modification, to enable a few more algorithms in there took months to finish because of the handshakes that were involved. And there was no infrastructure, so to speak, that could be shared between the two, right? And essentially the build systems that were developed by the OS vendors were basically developed in such a way that they couldn't be shared so easily across to, say, your customers. So because they were feeding into building these tools and rootfs that would basically combine as a customer deliverables in the end. So obviously, in many cases, people went to this route where they said, okay, we'll use this pre-built RPMs from you, and then we'll have some way, hackish way of taking your tool chain and then building around another build system, kind of a offshoot of it to compile our OpenSSH or what have you, and then combine it together in the end. So, you might see that as I'm describing it, how difficult it would be to maintain such a system.
Yeah.
And so that was actually a telling difference to me where I said, I've been thinking of, can we have a mechanism where we could speak the build system to each other, right? So we can share basically the build recipes rather than the build outputs. Mm-hmm. And binary distributions were there, right? Slackware was there, Red Hat was there, SUSE was there. Many of those binary distributions were available. And one thing that, the binary distributions offered was more standardized policy. And two standard systems like desktops and servers, it fitted really well because, all the systems came with a standard hardwares. And, these binary-only distributions made a lot more sense for these. But then for the embedded space, that was not the case because, hardware were different in many cases, customized. So obviously taking, those technologies together wasn't kind of fitting well. And there was some new invention needed to be there for us to be able to cater to those requirements. So I think what you just mentioned, exactly where people were trying to fit into these smaller systems. And then, you were looking at building everything from scratch actually was a need that I was sensing from the other side while I was kind of working at an OSB. And so I had my take at Gen 2, back in those days, I tried to basically use a Gen 2 desktop myself. And so I was trying to build things from source and trying to assess how difficult would it be if I were to give you a mechanism that you can then execute on your system and build the artifacts from source. So I think it was interesting times at that moment. So, there were build root was there, UClibc. Basically, build root was put together to package and deliver BusyBox and UClibc, essentially, right? And it grew from there. And obviously, at that point of time, if you were to do something like a Palm Top or a LCD display device, which is a little bit more complex with graphics and all, then you didn't have everything in there. There were various things that people were putting together, and I'm pretty sure that, in your experience, you would have had similar experiences and, your share of developments back in those days. So how was it when, you were doing the Windows CE development and then the transition from there to embedded Linux, and obviously talked about, the changes that you were seeing. But then what was the next step that you experienced after that, how things started to change?
Yeah, so, we were working on these PDAs back in the day, the Compact, and then the Sharp Zaurus came out, and everyone was kind of interested in that. And about that time, a developer named Chris Larson started a build system called Open Embedded, and Open Embedded was like the first true build system for embedded Linux that I used that could build everything from source and cross-compile on an x86 machine for other architectures such as ARM. And this was very, very important because when you're doing embedded systems, you need to be able to build everything for several reasons. One is you might need to change it, like you already mentioned with your OpenSSH example. The other thing is some of the system may be GPL licensed and you're required by license to provide the source code. So how do you really know if you even have it unless you can compile it and build it? Mm-hmm. So, and just if you're using a binary distribution, there's pieces that you don't have control over. So, to build these embedded products, it just seemed like a great thing to have a build system where you started off with one command and it builds the entire system with very few dependencies. So this immediately attracted a lot of interest and a lot of developers, and I'm sure you came on pretty quickly.
Right.
And really that's kind of been the basis of all of my embedded Linux development since then, is the Open Embedded build system, which has evolved and changed quite a bit. Mm-hmm. About what time did you get involved in Open Embedded?
Yeah, so I think I started, around 2006, I started to kind of play with it a bit earlier. Mm-hmm. And so I had one of those Zauruses, and, I said, can I put my own ROM on it? And so, it was more like my hobby project more than anything. So that's where, I bumped into Open Embedded, and I said, oh yeah, this would be something that, I can create my own ROM and, flash it there. And so that was kind of my first foray into it. And I learned quickly that, remember I mentioned about the OpenSSH case, and this was kind of running in my brain as a background thread, so to speak, that could there be a better system? And this seemed to fit in that bill as well. And so I remember going to my VP of software and saying that, hey, we know that we've been using this our home built build system for a long time, and it's working well, but there is this thing called Open Embedded. It has a task executor called BitBake, and what it can do is it can build things from source. And not only that, but basically I could just hand the build system to someone, and they can build whatever I'm building. So I'm not really transacting with them with, binaries that I produce, but rather with the source. So, but, it was kind of not taken very seriously, because I think obviously it's a new thing from a business model perspective. And so eventually I know that, most of those OSVs, they started using Open Embedded, but I still remember that conversation, and, it was kind of my excitement more than anything else at that point of time.
Yeah.
And I tried to then work through one of the things that I tried was, there was QEMU support. So I said, can I use, again, it went back to my compiler thing. So I said that, can I create a project that I can showcase to my VP and then buy in some of the credibility of the project. And I started doing a project on my own, basically to take the QEMU and trying to basically bring up a root file system on it, and trying to show that, hey, I can connect from my host to the QEMU, which is running ARM, or simulating ARM code rather, and then I can step through the kernel. And this was actually serving two purposes. One was that I wanted to learn about the kernel itself. And secondly, it would also be kind of a proof of concept that I could show. So that's, how I kind of then started looking into it. And then obviously, I think one of the areas that the project required to be filled in was the toolchain area. And that was my kind of initial contribution into the project, were around toolchain areas. And toolchain is so essential, so central to any build system. And it's a little bit hard to put together as well, especially if it is cross compilers. So then I started to use the build system and ran into issues, and I started fixing them one by one. Some small changes, starting with like some comment fixes and understanding the system, and then what all changes I kind of did for all this, my POC, I started upstreaming them. And I remember interacting with Chris Larson, Kuhn, and others who were actively, working on the project at the time. And they were very appreciative of any contributions that you were making that kind of, gave you satisfaction. So that was my start with the project at that point. And and then I just realized that the project was kind of a push model. So, you were contributing and somebody else was taking your patches, making sure they are good and they are kind of okay, and then they will push it. And then eventually, if you submit enough of them, then they kind of, somebody tells, hey, this guy's been contributing a lot. Why don't we kind of give him the push access, right? And then you gain the push access. So we use this push mechanism to maintain the code. And I became a developer, and I was pretty new, and many times, more than once, it so happened that I was on the West Coast, and I would fix my problem and commit it. And then somebody will wake up in Europe a few hours later, and then they will say, who broke this? And then they will have to go and fix it. And soon, we realized that, as I think we were recruiting more and more developers at that point of time, it was becoming evident that, stepping on each other's toes was becoming a lot more common. So I think that was very interesting. But from there, I think we moved to several other technologies and things. So I think used Monotone to do the source code management, and then I think we migrated to Git at that point of time. And I remember that Git was actually being used at Linux kernel, and it used pull model. And I think there was heavy discussions around push and pull models. And obviously, there were two divided thought processes at that point. And I'm sure that, you also had your exposure to Git and these kind of like source code management technologies. And so what was your take on Git? When did you get started, and what was like, your experiences? I would like to know about, it would be interesting to learn about, how your take is on Git at that point of time.
Yeah, Git is an amazing tool, and I just looked it up the other day. It came out in 2005, so about 15
Mhm.
years ago, and it really addressed a real need in software development for distributed development, and it solves some problems that no other tool to date had solved. And yeah, I remember those discussions in the open embedded community about which version control system to switch to. And we started with monotone, and then I think we were considering one other one. Do you remember which one that was?
Yeah, I think it was
uh,
Mercurial.
Mercurial, yeah. So I remember those debates, and I definitely chimed in on those. But one thing you have with Git is cheap branching. You know, it's very efficient branching model, and I don't think anything else at the time really had that. And after I had used it and really used it enough to understand that, it was just clearly the way to go. And I'm glad it did go that way. But one other thing I remember about the early days of Git is trying to convince my customers to use it. So everybody was using Subversion at the time and thought that was great. And along comes Git, which adds another layer or two of complexity in some ways, you know, because you have the whole repository local in your workspace, and then you have a remote. So there's an extra step there in pushing changes because you have to commit them and then push them. So that was a little bit difficult for people who had never used Git or didn't have a lot of motivation to learn it. But to really be effective in open source, using Git is just a given now, but 10 or so years ago it wasn't. So yeah, those were interesting times, and it was just so interesting to watch people after a week or two of complaining about Git, all the problems they're having. You know, suddenly the light bulb would go on, and suddenly they were quiet and they loved it. You know, so it's an amazing tool and really has contributed to the success of Open Embedded and you know many other projects.
Mm-hmm. Yeah, certainly. I think Open Embedded kind of started to use Git, and we started seeing a lot more activity and a lot more stability, at least from the SCM point of view, and a lot more control actually kind of like was exercised by the developers at their workstations, and that kind of resulted, I think, in a lot of increased quality of contributions at that point. So I
Mm-hmm.
think I'm thankful for Git actually to be there, and I think I'm happy that we made that switch back then, and have been ever since using it. So I think essentially what I also saw was some developers in Open Embedded were more on the Git front and more than others. And that's what got me into Angstrom distribution, so to speak, right? So I wanted to play with Git, and Angstrom distribution was already playing with it. And I said, well, it is Open Embedded based distribution, and let's try it out. And so that was also interesting outcome from there. And then at that point of time, Angstrom was one of the, I think, popular distributions that was using the Open Embedded build system. And there were a bunch of others that were created. I think Proton comes to my mind, and others. Pocky comes to mind, but Pocky was kind of always a reduced kind of. What Pocky did is it took Open Embedded and modified it quite heavily. What Angstrom had was it has some genesis from Buildroot, and then at one point of time it decided to use Open Embedded straight away. So it didn't have a lot more history with the project other than that let's consume it as it is. So that was kind of an easy to adopt kind of distribution for me at that point of time. Yeah, so so we had like it was a monolithic repository, so there were more than one distributions in there. You would see if you even today look at the repository, then you would see there's a minimal distribution, there is a base distribution, there are many others. There is SlugOS, and so there were several other incarnations that were actually built in. I think one of the things that started to happen during that time was that people started to report their test results and build results. And I'm sure you were also participating in that at a certain point of time. And I'd like to hear your thoughts on that. That kind of initiatives where a open project can kind of collaborate and use the output from various developers who may not be working on the same thing, but basically can benefit each other by sharing information like this.
Let's see. Are you thinking about the testing effort we had at one point where we would all test on different targets? And yeah, so that was so at one point we started up this testing effort where I think we would tag open embedded, and then everybody would build that tag or something on for the particular targets they were working on, and then report back test results, what image you built and did it work? Are there any problems? And we kept a spreadsheet of those results. And that was a really fun effort. It's probably something we should do again in some form or another. But yeah, there was really a lot of interest in testing at that point, and people were contributing and running these tests. So it really contributed a lot of feedback into the project at that time, and no doubt helped it to become more versatile and complete. Mm-hmm. One thing Open Embedded offers is a very flexible, and it can be targeted to a very broad range of applications and image sizes and machines. We talk about the Angstrom distribution, and that's what I used for years on all of my projects. I started with the Angstrom distribution and then customized it from there. But what is a distribution? I mean, is Open Embedded a distribution? I mean, that seems to be a point of confusion.
Yeah, I think it's like distribution builder, so to speak, right? So essentially, and it's interesting that I was at one of meetups, and the meetups was about open source and embedded Linux and things like that. And we were talking about Open Embedded and other things, and people were saying, all right, so Open Embedded is a distribution, and I said, no, it is actually a distribution builder. And everybody was kind of like blank faced. They said, what do you mean? And so you have to explain that, yes, so, when you talk about, Fedora or Debian or SUSE, they are distributions, but then there is infrastructure behind which builds that distribution. So Open Embedded is something similar to that infrastructure. What happens is, I think I realized that the point of confusion is because it's so accessible. It's a Git repository, right? So you go, you check it out, and you are basically not checking out a distribution or a application project. You are checking out a infrastructure that will build you a distribution. So I think that kind of like is a unique space for the project, and people kind of misunderstand it, that it is a distribution, but actually it is not a distribution. It is a distribution builder. Because distribution, what does distribution consists of is, policies, right? So you have certain policies around packages, which packages you want to ship, what architectures you want to support, which libc you want to use, which init system you want to use, what your licensing policy should be, right? And you can go on. So there are several policies you can impose on your distribution. I just listed a few of the common ones, but there could be more. And when you combine all these policies, then you get a distribution. And then distribution could have all these policies defined based upon its end users and the needs of its users. But for Open Embedded, it's an open-ended infrastructure. So when you use it, essentially, you are building your own distribution. Now you can get templates in there, right? Which could be, nowadays it's called no distro. And hopefully that's telling enough for people to say that what you are checking out is a no distro. right? And you then adapt it to your own needs. So that's my take on what a distribution is and what a distribution build infrastructure is.
Yeah, that's I think over the range of products I've worked on projects, and some of them are tiny headless little edge gateways that have a 25 megabyte rootfs image, and
Mm-hmm.
use muscle for libc and a real minimal busybox type setup. And
Mm-hmm.
then I have other projects where we're running on quad core, very powerful processors, running systemd and glibc, and where we're running more of
Mm-hmm.
a full stack. So the beauty of open embedded is we can target any of those use cases with one tool, and each project can have a custom distribution
Mm-hmm.
that matches what it needs, rather than taking kind of a one size fits all approach. So that's worked very well in my experience, and
Mm-hmm.
really is the power of open embedded. I guess the other thing that has been really helpful is open embedded has a very um, large number of recipes. In other words, it can build about anything. So if you need a component in your system, chances are there's a recipe for it already. These recipes aren't trivial in many cases, because cross compiling is very hard, especially with auto tools and C projects and all the dependencies. So open embedded provides a tremendous amount of value there in capturing that knowledge, how to do this very hard task. And somebody only has to figure it out once, and then the rest of the community can use that.
Right. Yeah, I think this is like what you mentioned there is a very valuable point, and I would like to expand a little bit on that. So auto tools have basically been developed to build on a system where this package would run on as well.
Mm-hmm.
So what they do is they go and they poke at your build system, and by poking I mean they poke at, so they would run a compiler, right, the native compiler, and say, let me find out what's the size of integer on this box, or what's the size of wchar, right? And the second thing that they do is they will emit a small snippet of code, and then they will really execute it on the box, and then inspect the output, and then make a decision to configure your project. So now what happens is when you're cross-compiling, right, then if you do that, then you are going to get wrong values, because as we know that you might be building on a 64-bit build system, but you might be targeting a 32-bit build system. So word length is not same, and endianness might not be same if you are doing like MIPS, big endian, and you're building on a x86 64 little endian. So there are several quirks there that it can silently get it wrong if you kind of try to build it. So what has happened is in Open Embedded, this is a collective knowledge, collective information that has gone into cross-compiling these kind of packages, as well as what Open Embedded has done is it has kind of containerized them, where they say you cannot run a test case on the system, right? So there's a cross-compile badness that will be triggered. So there are several tools and helps that you get along with a very deep kind of knowledge that has been collected there in cross-compiling some of these complex packages that will just work out of box nowadays. So
Mm-hmm.
yeah, I think that's a really good point that you touched on, and so I think let's talk about the OE build. I think that was the template that you put together initially, and then I also joined you on developing that because you put it out on GitHub as one of your projects. So what was behind OE build, and why did you decide to put it on GitHub?
As we're doing projects, we need a build system or some way to capture the build configuration. So I started with the Angstrom setup script. I guess we call them setup scripts, maybe.
Mm-hmm.
And these are basically a make file. I think in the early days it was a make file, and then kind of evolved into a bash script. And then there's different things people use on different setups and projects. So, this kind of started as a make file, and then it would, we would capture all the knowledge required to actually run the build in Open Embedded using BitBake. So then at one point, I had a brief exposure to an Android project. I haven't done much Android development, but on this project, they had a env setup.sh script that you sourced in a bash shell, and then this env setup file would actually populate your bash shell environment with functions. And then these functions could be run anywhere once you source the file. And this is a little different than a make file or a traditional bash script where you actually run the make file or you run the script for every operation you do. For some reason, that just really clicked with me. I'm not sure why, but it just seemed like it was a nice way to do things. So I adopted that method of doing things. And if you look in the Yoe distribution, there's an env setup.sh script that's kind of the top level of the build system, if you will. And one of the nice things about this method of doing things is we prefix all these functions with Yoe, Y-O-E. So then to immediately see all your functions, you just type YOE tab, and boom, you get a whole list of functions that you can run to do various operations. Mm-hmm. So that's kind of where the OE build repository came from. It's something I put out on GitHub because I started using it for all of my projects, and it was just kind of a common starting point, a template, if you will, to get started.
Yeah, I think once like Open Embedded kind of had a re-architecting done where we went from a monolithic repository to this layer-based systems, it became more or so important to have a mechanism to put these templates together. And I think that's where I think it really shined, because it would basically use a mechanism to set up your workspace. It will provide you functionality to do certain common operations. And I think from my perspective, it was like really a top level workspace setup and a daily driver for somebody who is doing day-to-day distro work. And that is what kind of attracted me towards that. And obviously, I was doing Angstrom at that point of time, and this was kind of a small step for me in addition to what I was already doing. And it offered me a really good control set of requirements that we had back then. So one of the things we were trying to do at Angstrom was how can we lock the layers, right? And because of this new architecture, now you had recipes and metadata coming from various other layers, along with a core layer that was called Open Embedded Core. And then the task executor was BitBake. That was already always a separate project. So you have a BitBake, and then you have Open Embedded Core. That kind of gives you a very minimal system, so to speak, right? And then you combine some BSPs together to basically form a project that for a given device that you're working, say, if you're working on a Raspberry Pi or BeagleBone, then you'll pull in Meta Raspberry Pi or Meta TI and then add it. And that would basically bring in all the board support package for those. So, and then there were also like software layers, that would give you additional features, things like Qt5 and others. So in the end, you had to manage at least 6 to 10 layers, right? And so what OE Build gave me was a mechanism to manage that, and I could easily add, delete layers. And so one thing that I think it was different at that point than others, there were people who were trying to create like similar functionality And there was this combo tool that the Yoe Distribution used, and it has always used something of that sort in the past as well, where it fudges together bit-bake and open embedded core and other layers that you have to into a single monolithic repository. But one downside is that it doesn't share any history, so you have to like kind of create a new history. And I preferred it that way, that I could still manage to look at the histories of the upstream projects like Open Embedded Core and everything individually. So OE was using something called Git submodules. So would you like to talk about like why Git submodules was something that you chose? And because I know there were like things like repo, the Android repo tool, and some layerman tools that were home built shell scripts and so on and so forth. And so what was your thought behind that?
Yeah, that's how you manage multiple Git repos in one project has been a big question, and there's been a lot of solutions developed to handle this. And the Git project has a built-in feature called Git submodules. It's very simple. It just simply pulls in another repository at a specified hash, and so it's incredibly simple, and it's meant to be used with kind of a parent repository that then has sub repositories, kind of nested inside of it. And I guess using Git submodules is kind of it's kind of an unpopular. Git submodules are kind of an unpopular thing. They're a lot of people don't like them, and so I've really questioned this decision over the years. But I just kind of think back to the struggles my customers had even using Git in the first place. From that kind of came the conviction that this needs to be kept as simple as possible. We're not, the open embedded tooling is very good. It is, quite good. There doesn't need to be a lot of extra stuff added on top of it to really build an embedded Linux image. So my desire was to keep it as simple as possible. And I believe Git submodules satisfies that requirement. And it's also very good from a product standpoint, because when you're developing product software, you have to have everything controlled. You can't have versions of stuff changing on you without you knowing it or specifying that you want it to change. Because that's part of the repeatability. Your build system has to be 100% repeatable. You load it on machine A, it builds the same output as when you load it on machine B tomorrow. It'll build the exact same output. So that's an essential requirement, and Git submodules satisfies that. And then over the years, the functionality of Git submodules has improved, and it's actually a pretty nice user experience. The only real problem is if you make a change on a submodule without checking out a branch first, you can push your changes to no branch or whatever they call it, and that can be a little confusing for people. But typically with an OE project, we have maybe, like Kim said, 5 to 10 layers. Each of those are a Git submodule. So Git submodules handles that number of repositories very well. Now, if you had hundreds of Git repositories like an Android build would have, then maybe you could justify a more complex tool like repo. But I think for what we're using it for, it's a very good fit.
Yeah, I think I agree with you there as well. I've come to my own terms, and I think I've started to like it. In fact, once kind of you get your head around Git, learning Git submodules is just a very small step. And I think if you understand a little bit of quirks, then they are really productive. And we have also, I think, provided some of the Yoe tools actually that kind of takes that pain away. So there are tools like you can add layer, add the repository, delete a repository. So we have like a top-level functions in our setup scripts. So I think that basically takes care of a lot of the day-to-day issues that one might find. And so I think it's pretty usable at that point. One thing I really like about it is that I could create summary of the project of the monorepo, and it tells me where my all layers are in terms of their upstream branches. So say I modified 3 repositories, and it'll tell me exactly what those 3 repositories contain. So that's really good to know. And there are several other goodies that it provides, but I think overall the simplicity and the repetitive builds are I think the key points that I think we keep using it. So that's pretty good. So I think we are perhaps at a top of our hour, but I would like you to also give some quick overview of Yoe Distribution. And I know that it came from OE Build, and what it is now, and what we are looking forward.
Yeah, we use this OE Build template for quite a few years, and then recently, you and I have been kind of discussing where to go with this, and it kind of occurred to me that maybe we should split this out into its own project and its own organization. So we decided to do that. We came up with the name Yoe. It's basically a combination of the Y in Yocto and the OE in Open Embedded to form Yoe. And it's also the name of a female sheep, I think, which is kind of neat. And so that's now its own organization on GitHub. Mm-hmm. So I guess the desire going forward is just simply to be more of an independent open source organization that anybody can participate in and help make it usable as a simple template for using Open Embedded.
Mm-hmm. Yeah, I think that's a really good start. And I think what you'll also see is that all the layers that the Yoe distribution is supporting are actually mirrored onto the same organization as well. And we use the same layers from the same GitHub projects into Yoe Distribution. So that kind of gives us some level of control and as well as some redundancy. If, say, upstream layer goes away or gets rewritten to or something, the project can still go on. This also gives us actually a lot more flexibility to do continuous integration and create branches, which we are doing. So we have our own CI system. So I think looking forward, what we think is that Yoe can basically be that deployment platform that people want Open Embedded to be. And it could be basically serving as a deployable from day one project for the end users. So what are some of the future milestones that you think we should work towards?
I guess some of the things that come to mind for me are just broader platform support. We already support quite a few, but as we talked about testing earlier, I would really like to get back into testing more platforms on a routine basis. Mm-hmm. I guess we've discussed feeds. I think it would be kind of neat to have one configuration or so, and maybe generate binary feeds for people, mm-hmm. so they could quickly install packages, on a Raspberry Pi or something. It would be more like a Debian type experience. Mm-hmm. That would be mainly just allow people to quickly evaluate and use the distribution. Mm-hmm. There's a lot of things. We have a software updater in Yoe right now, and we're looking at integrating some other software update technologies. So there's a lot of opportunity and a lot of exciting things coming on. And I guess, in a summary, we picture Yoe, the Yoe distribution as a real thin wrapper. We really try hard to not add a lot of complexity. And that's one of the reasons that a shell script was chosen kind of for the top level automation, is that it's really simple to read because it's just commands, just shell commands, same things you would type if you wanted to type it out manually. Mm-hmm. So it serves as good documentation, and it doesn't hide anything. Mm-hmm. And it's also very easy for you to add your additional ENV setup scripts, mm-hmm. that might wrap the ENV setup script where you would put your own project automation in it. So it's easily extensible. There's no magic. It just kind of helps you use what the power of open embedded and what's already there.
Right. Yeah, I think that's really a good point there. I remember once, I was kind of writing a SD card and I DD'd directly into it, thinking that I DD'd into the right device. But it so happened that, it was system has rebooted and I've found that UDAV has decided to mount it in a different order. And I ended up writing to one of
I hate when that happens.
Yeah. So what these kind of commands give us is actually really that abstraction that takes these kind of worries out of your mind and lets you concentrate on the real work at hand. And I really appreciate that because every time we are kind of distracted into these activities, our focus on the problem is not as deep as it should be. And, many times you would be working on like a very difficult problem and then suddenly, you have fixed it, you think, and then you built your image and you want to flash it. And suddenly if something goes wrong because of all these tools really come handy in that regard that you can like just execute them and they do their work. So I find that more and more that I'm immersed in the problem rather than in the build system. So, that's a really helpful activity, I believe. And I think we'll keep making it better and simpler. So I think, as you rightly mentioned, that Yoe is all about simplicity and determinism. So we strive towards making it easy for people to consume open embedded based products and develop their own. And at the same time, we are not shy of using new technologies either. So I would just like to mention that we support like new, architectures like RISC-V. We do regular testing on, QEMU for RISC-V and also the Freedom Board from Sci-Fi. And we are kind of using Clang at certain point, as well as a system compiler for testing a few images. So, and we make sure that if you want to use Clang with open embedded, then Yoe has simple switch in our templates to set toolchain and things like that. So, so I think that's basically. I'm very excited about the project, and I think it's just started. I think, and we have more to go. And now that Yocto has also announced that 3.1 will be a long-term supported release, we do have plans to support our 3.1 based Yoe release for that long as well. And I think our focus will be there to make it even better for deploying and addressing more and more end user scenarios from deployment perspective. So I think we want to position it into people who are deploying real products and address their issues in terms of workflow or otherwise. So I think that's been our focus on this distribution. And I think what I've seen is that it basically also helps the core developers in the end as well, but it may not be that their focus might not be exactly on the things that we consider in Yoe. So.
Yes. Yeah, that's an excellent summary, and really we're definitely interested in what all of you think, and ideas or contributions are welcome. So we definitely look forward to engaging with the community and others in these efforts, and we can all benefit.
All right. So I think thank you very much for this nice discussion today, Cliff, and I really enjoyed talking about way back when we started and what brought us to creating the Yoe distribution. And I hope we will have a lot more follow-up interesting discussions around various technologies and processes in and around Yoe distribution, but not limited to just Yoe distribution. We'll also cover as we see fit and interests us. So thank you. And so any last words, Cliff, you have for our listeners today?
No, thank you for joining us, and we look forward to the next one.
All right, thank you, and God bless.
Yep.